We're going to do some review and practice for your quiz. As always, it's better if you try first the problems and then just, check your answers at the end. All right, so each polynomial is given in factored form. State the overall degree. So if I multiplied this all out, we're going to state what each zero is. So we should be able to figure out the zeros, even though we haven't spent time yet in this unit. And then state if the end behavior goes up or down. So what's the degree? If I took x cubed and multiplied it by x and multiplied it by x squared, how many x's would I have overall? X cubed times linear x times quadratic x squared. So I would have x to the sixth. And on your quiz, I'm not going to have it in factored form, so don't worry about that. But if I had it to be x to the sixth, the leading coefficient in this example, you probably wanted to say -5, but because we would have had to multiply this all the way out, I want to tell you what it would have been. What is 3x squared? It would be actually 9x squared when I multiply that out. And then what is the biggest term? So 9x squared times -5x cubed, because this x is going to be times x. So it's actually a leading coefficient of -45. So again, if this and this were tripping you up because it was not in standard form, don't worry about that for the quiz. Now that you know the degree and the leading coefficient, you should be able to state the end behavior. So if the leading coefficient is negative, the right end goes in which direction? Negative goes down, right? It's not happy. Then you look up to the degree. This degree is 6. Is that an even or an odd number? If it's even, they're going to go in the same direction. So what the right does, the left also does. Now, the zeros you're not going to have to identify on this quiz, but this is just helping keep our last unit kind of current in our brain. In this factor, x would have to be 0. In this factor, x would have to be -5. And in this factor, x would have to be -1/3 in order to make those factors equal 0, which is what you learned in factored form on the quadratic test. All right, on this example, we have a quadratic times a linear function. X squared times x would be x cubed. I could actually say 6, right? My degree is 3. The leading coefficient is going to be +1 because all the coefficients of x are 1. 1 times 1 times 1 would be 1. The zeros would be at +5 and at -8. All right, for the right end behavior, if the leading coefficient is positive this time, the right end is happy and goes up. If the degree is odd this time, odd and opposite both start with O. So one goes up, the other goes down. All right, so a little bit of practice with division. So if you need help setting these up, you put your x plus 3 down the side of your box, and you start putting your dividend inside the box, 4x cubed. How am I going to get 4x cubed? X times 4x squared. So I am going to fill in 4x squared here, and then I'm going to fill in this box. 4x squared times 3, 12x squared. So now on the diagonals are my like terms. How many x squareds are in this dividend? -3. I'm currently at +12. What do I need to add or subtract to get to -3x squared? -15x squared. Those two together subtract and give you -3x squared. Now I can do the top of the box, because this number times x has to give me -15x squared. So -15x is the next term in my quotient. Once I have a top of the box, I multiply to get inside the box again. So -45x. I look on the diagonal again. I wanted to get 7x's. I'm currently at negative 45 in the whole, so I would have to add 52 x's to bring that value all the way up to 7. So this number is big, 52 times x, and then 52 times 3 would be 156, right? Because 50 times 3 is 150, and then 2 times 3 is 6. So I have a huge remainder because I only wanted to end up with 1. So I have to subtract 155 as my remainder. So my final answer is 4x squared minus 15x plus 52 with a remainder of negative 155. That was a huge problem. All right, the next one. X plus 3 goes down the side. Okay, and x cubed goes to start it. So that puts x squared in the quotient spot. X squared times 3, 3x squared. I'm trying to get to 7x squared, so I want 4x squared. So that's 7x squared all together, right, on the diagonal. Once I have this box, I can do up here. 4x times x is 4x squared. So I can put a plus sign there in my quotient. Now I do multiply this times this. So 4x times 3 gives me 12x. On the diagonal, has to add up to 13x, so that would just be x, right? 12 plus 1. How do I get something times x to give me x? It must be plus 1 up here. 1 times 3 is 3. Hey, I don't have a remainder. I wanted exactly 3, and I ended with exactly 3. So my answer is x squared plus 4x plus 1, no remainder. All right, this last one, it looks like it would be harder, but sometimes it's easier to have more terms in your divisor because the problem will get finished faster. So the more you're dividing out, the faster the problem goes. 5x to the 4th sits in here first. So I need 5x squared times x squared to get 5x to the 4th. 5x squared times 2x would be 10x cubed. 5x squared times 1, 5x squared. I need how many x cubes? I need a total of 2. If I'm at 10, I have to subtract 8 of them. All right, what goes up here then? What times x squared will be negative 8x cubed? Negative 8x. So I follow that down. So this one would be negative 16x squared and negative 8x. All right, look at this diagonal. There are 3 boxes in this diagonal. We need a total of x squared. Right now I have 5x squared minus 16x squared. So I'm currently at negative 11x squared. So I would need 12x squared so that these 3 add up to 1x squared altogether. So plus 12 is the last term in my quotient. And I do 12 times x squared, 12 times 2x, and 12 times 1. So this remainder, I have to get 4x minus 2. How am I going to get 4x? I currently have negative 8, positive 24 is 16. I would need to subtract 12x to get to 4x. I'm currently at 12. I would have to subtract 14 to get to negative 2. So my remainder is negative 12x minus 14. There will not be as big of a division problem on your quiz. I'll stick with a binomial as your divisor. All right. Perform the given operation. So you're going to add together the two functions or subtract or multiply or divide. So I highly recommend that you try example 4 before checking your work. Now I'm going to do the problems. F plus G. So we'll have x squared. I have 2 minus 3. I have negative x. And then 7 plus negative 9 is negative 2. Now I'm going to write this one out. H of x, but I'm subtracting f of x. So I actually have negative 2x, negative 7. So I have 2x cubed plus 1x plus 3. Now I'm multiplying. So oops, f of x is 2x plus 7. G of x is x squared minus 3x minus 9. 2x cubed minus 6x squared minus 18x. 7x squared minus 21x minus 63 gives me 2x cubed plus x squared, 39 minus 39x minus 63. G divided by f. F is 2. Oh, I should not have given this problem. Well, let's see what would happen. You're going to end up with a fraction. So let's see. I need to get x squared, right? So, right, I'm taking this quadratic and dividing by this binomial. So to get just x squared, I would have to have 1/2 x. Usually I won't have you do 1/2 x. What's this going to come out like? 3.5x. And then how many x's did I want in g of x? I wanted negative 3 x's. So I'd have to subtract 6.5 x's. I won't have you do one that has a decimal, so I apologize. Let's see, so what times 2 is negative 6.5? What times 2 is negative 6.5? 3.25. Negative 3.25 times this gives me this, and then I do this times this to get this number. 3.25 times 7. Ooh, 22 3/4. Yeah, this one was too hard. I needed to get to negative 9, so you could figure out the remainder, but that would be the gist. There won't be one like that where you're dividing with a coefficient of 2 right here. What if I add together the first two functions and then subtract h? I'm going to write this one out. 2x plus 7 plus x squared minus 3x minus 9 minus 2x cubed plus 3x plus 10. I'm going to distribute negative 2x cubed minus 3x minus 10. All right, so negative 2x cubed would go first. How many x squareds do I have? Just this guy, right? Plus x squared. I have 2 minus 3 minus 3, so negative 4x's. Then I have 7, negative 9, negative 10, so negative 19 plus 7 is negative 12. All right, the last one with this function notation is I'm going to plug in 5 and see what I get. When I plug in 5, I get 2 times 5 plus 7, 17. Now I'm going to plug in negative 1 and see what I get. I would get positive 1, positive 3, negative 9 is negative 5. So add those together and you would simplify and get 12. So now let's see, f of x is linear. So pause it, try naming these. Don't just look at the answers or you're not going to know how to do it on the quiz. Linear binomial. G of x is a quadratic trinomial. And a cubic, also trinomial. Remember, if there's more than 3 terms, you could just call it a polynomial. A quadratic binomial with leading coefficient of 8. 8x squared plus 2x, right? Quadratic, binomial, leading coefficient of 8. Give an example of a polynomial whose left end goes down and right end goes up. So I could use 8 as my leading coefficient and just have an odd degree, something like that. So 8 is the leading coefficient, the right end goes up, odd opposite will make the left end go down. I hope that was helpful.